Hi guys, welcome to the Pandas data structures lecture. Series and data frame are two workhorse data structures in Pandas. We will talk about series first. Series is a one-dimensional array-like object which contains values and an array of labels which are associated with the values. Series can be indexed using labels. Series is similar to Numpy Array. Actually, it is built on top of Numpy Array object. Series can hold any arbitrary Python objects. Let's get hands-on and learn the concept of series with examples. As usual, this reference notebook is provided in the course material. You can always come back to explore more in this reference notebook. To start with, let's create a new notebook and start working in that one. So the first thing first, we need to import NumPy and Pandas. We know we import NumPy as NP, and let's import Pandas as PD. NP and PD are alias for NumPy and Pandas. So let's run this cell. We can create a series using list, NumPy array, or dictionary. Let's create these objects and convert them into Pandas series. So the first thing we will try series using list. So let's create two lists, my label equal to say x, y, and z, and my data equal to say 100, 200, 300. Let's talk about my data first and convert this my data into Pandas series. We can access Pandas series as pd dot. We can shift tab and autocomplete, and if you want you can shift tab and explore more about the document string. Let's talk about data at the moment. So we pass in data equal to my data, and let's run this cell. So we got our series. Column 0, 1, 2, which is this column here, is automatically generated index for the elements in series with data 100, 200, and 300. We can specify these index values and call the data points using these indexes. So let's pass my labels to the series as index now. So pd dot, we can shift tab again to do autocomplete and say data equal to my data and index equal to my labels. Let's run this one now. So now we have x, y, and z as our index and 100, 200, and 300 as our data. We can write this code as my data and index as well. And the reason is if we explore shift tab, we see that the first one is data and the second one is index. So this is already in order. So instead of writing data equal to my data, index equal to my label, the series will take the first one as data and the second one as index. So let's try to create series using NumPy array. So first thing we have to create an array, my array equal to, we know we can create NumPy array with np dot array, and we know we can convert the list. So let's pass in my data here, and let's run this cell and print this one. So we have a NumPy array 100, 200, and 300. We can convert this pd dot series and just pass in, instead of list, pass in this array here. We can say data. We don't need to, but we can still say data. So data is my array, and this is now Pandas series created using Numpy array. So similarly, we can pass in index as well, which is index equal to my label. So we get the series from Numpy array. Dictionaries are very useful to create Pandas series, and I really like this to create Pandas series using dictionaries. Let's create the dictionary first and then convert that dictionary to Pandas series. My dic equal to x 100 y, say 200, the same data we can use, and z 300. Let's run this thing and see how the dictionary look like as usual. So we have dictionary x, y, and z are the keys, 100, 200, and 300 are the values. So let's pass in this dictionary to pd.series and run this cell. Now we have series from our dictionary. Notice the difference here. If we pass in the dictionary to series, Pandas will take the keys as index or labels, and it will take values as the data. This is quite convenient way of creating series. Series can hold a wide variety of object types. Let's see with some examples. So instead of passing data as my data, we can say pd.series, and we can say our data is my labels, which is actually a list of strings. So series can hold strings as well. So just for an example, let's pass in built-in function to series pd.series, say list of some functions, min, max, sum is another built-in function, print. Let's run this thing here. So we have a Pandas series that has built-in functions minimum, maximum, sum, and print. This is just for an example. You may not see this in the real world actually. Now once we have series, most important thing is how to grab data from series. So indexes are the key thing to understand in series. Pandas use these indexes, which are names or numbers, like in this case we have x, y, z, and in this case we have 0, 1, 2, for fast information retrieval. Index work like a hash table or a dictionary. To understand the concept, let's create 3 series. So let's create dictionaries first. Say we have Toronto 500, Calgary, Calgary 200, Vancouver, say 300, and Montreal, say 700. Second dictionary we can create. Let's copy this one and let's delete Toronto only, and we have Calgary 200, Vancouver 300, and Montreal 700. So let's create another dictionary, and along with these three add another city, say Jasper, which is a very beautiful place to visit if you really want to drive to the Rockies in Alberta. So let's run this cell. We have three dictionaries, dic 1, 2, and 3. Let's rerun this cell now. Okay, so let's create series 1, sr1 equal to pd dot series, and what we need to do, we need to pass in this dictionary here. Let's copy this one, paste here 2 times, change this to 2 and 3, and this one is our 2 and 3. So what we did, we created 3 dictionaries, and then we are creating 3 series and passing these 3 dictionaries to pd.series. Let's run this cell. So the good thing is, check how these series look like. So we have ser1, ser2, and ser3. So these are our 3 series with where keys are now index and numbers are now data. Grabbing information from series is very much similar to dictionary. So what if we want to grab Calgary from series 1? Calgary. So we got the data for Calgary. Similarly, we can grab, say, instead of Calgary, we can pass in Toronto here, and we get 500 for Toronto. Now, one thing notice here, we are passing a string, which is Calgary here, Toronto here. Our index contains these strings, which are names of the cities. If the index is number, then we have to pass in number instead of this string. So just a quick note here, when we are only passing a dictionary, the index in the resulting series will have the dictionary's keys in sorted order. Let's give a look here. Like in dictionary 1, the first one is Toronto, second is Calgary, third is Vancouver, and fourth is Montreal. But when we printed this series, we got Calgary first, Montreal second, Toronto, and then Vancouver. So the order is sorted out in series with C, M, T, and V. If we don't want this order, we can override this by passing the dictionary keys in the order we want them to appear in the resulting series. So moving forward, let's talk about some basic operations on series. So the basic operations on series are usually based on the index. For example, if we want to add series 1 and series 2, let's try to add them first. So we have series 1 and series 2. What if we add series 1 plus 2? So this is what we have. So what's happening here? It tries to match up the operation based on the index. For Calgary, Montreal, and Vancouver, it adds the values like Calgary 2 plus 2, 400. Montreal, 700 plus 700, 1400. Vancouver, 600, which is 300 plus 300. So it's adding the values here. However, for Toronto, it cannot find a match, and the output is NaN. So let's say this is our series 4 and then series 4. So here it is. Now let's try to add series 5 equal to ser4 plus ser3 is our third one, and let's print ser5 as well. So here we have Calgary, Montreal, and Vancouver. It didn't find the match for Jasper and Toronto and returning NaN. So once again, the values found in the series were added for their appropriate index. On the other hand, if there is no match, the value appears as NaN, not a number, which is considered in Pandas to mark missing or Na value. So this is a missing data. So moving forward, let's talk about some useful methods and attributes here. Is null not null? Is null returns true if it doesn't find a value. However, not null returns true if it finds a value. Let's try to use these functions on say series 4. Series ser4 dot is null. So we have 400 false. This is not null. 1400 false. This is not null. The true value where it finds NaN, it returns true. So let's try not null now on ser4. So this one is opposite to is null. We have false and trues here. Axes and values are two very useful attributes that we can call on series. Axis returns list of row axes, labels, or index, whereas values return the list of values, which is our data. So let's call ser4 dot ax. We can shift tab, and here it is. We have ser4 Calgary, Montreal, Toronto, Vancouver. And what if we call values here? We got the data 400, 1400, NaN, which is missing data here, and 600. So let me introduce two very important and very useful functions here, head and tail. Keep it in your mind, we are going to use head and tail quite often. So head and tail are used to view small sample of series or data frame. Let's try ser4 dot head. If we press shift tab, here it is. It has a default number 5, but we can pass in any number. Say we can pass in 2 here. So this is the sample of our data in ser4. Head and tail is also used for data frames, and we will talk about data frame in our next lecture. We can call tail and it is showing the last two values, Vancouver, Toronto, and for head, first two, Calgary, Montreal. Size is another very useful attribute, and let's use this on ser4, and it returns the number of elements in your data. Like we have 1, 2, 3, 4 elements in our data, it's returning the number of elements in our data. Empty is another useful attribute here. Let's run this one. Empty returns true if the series is empty. So we are getting false because our series is not empty. So as a quick overview, in this lecture we learned about creating series from lists, Numpy arrays, and from dictionaries. And dictionaries are quite easy to create series in Pandas. So series can hold all kind of data, like these are built-in functions, strings, numbers, and then we learned about some operations on series, and we learned about is null and not null, how to know if the data is missing or not. We learned about the axes and values and two very important methods, head and tail, that we are going to use them in the coming lectures quite a lot. So see you in the next lecture where we will learn about the data frames to expand our concepts on series. Good luck.